Hi, my name is Sonali and I'm going to be doing a video about working with BAM files. The topics I'm going to be covering today are about reading in pair-end reads from a BAM files in chunks in small sizes, as well as reading in reads in chunks, performing a certain operation and getting back one final result which contains the sum of results from each of these chunks. So let's start with our demo. I'm going to be requiring 4 packages. 3 of them are software packages, whereas one of them is an experiment data package called Bacilla BAM subset, which contains BAM files from the Bacilla experiment. Here only the reads from chromosome 4 have been kept and they are aligned to the fly genome. So you can read up more about it by looking up the help page for any of these data sets. For my first part, I'm going to be using a BAM file, which is called untreated3_chr4. These contain pair-end reads. So first of all, I'm going to get rid of the PCR or optical duplicates and the reads which are not passing quality control using scanBAM flag. I'm going to give that flag parameter to the scanBAM param object. And now I'm going to make an rsamtools BAM file which takes the path of my BAM file and sets a yield size of, here I've set a yield size of 10,000 reads. So every time 10,000 reads will be read, then the next 10,000 reads will be read, and so on and so forth. Typically this number is larger, it's about 1 million. So, and you can even look at the output of this BF variable. It contains it's a class, where the path is, what's the index of the path, whether it's open or not, and the yield size. To quickly find out the number of reads in this BAM file, you can use the function called countBAM, and it will tell you the number of records which are present there. Let's open the BAM file and let's read in the first chunk. So you can look at the first chunk right here. It contains 10,000 reads. Let's read in the second chunk here. Oops, sorry. Let's read in the second chunk here and let's look at that output. And as you can see, the next 10,000 reads have been read. So now you can find out whether these all the chunks have been read or not by using this simple function called isComplete. After you've read all the files, you can close it. Now let's understand the output of a pair-end reads. So as you can see, the show method for GAlignment pair objects displays 2 ranges columns. One for the first alignment in the pair and the other for the second alignment in the pair. And the strand here actually comes from the first alignment. The SAM spec says that we should be keeping only proper pairs for our downstream analysis. So to find out how many pairs are properly aligned to the reference, we can use this table command on it, and we can find that only 4902 records are the ones which are properly aligned. So let's subset our gal-p to keep only the proper pairs, and as you can see, it contains only 4902 alignment pairs. I'm going to show you another example where I'm going to read the BAM file in chunks, calculate the coverage for that particular chunk, and then ultimately combine the coverage from each of these chunks to come up with the coverage of the whole file. So that is done using the function called reduce by yield, which actually comes from the genome files package, and it requires 3 functions in addition to the BAM file reference. So the first function is map, which is telling us what to do. So you're going to read in the read alignments chunk of reads from the BAM file. Then you want to calculate the coverage on that particular chunk, and then you want to ultimately combine the coverage from each of those chunks in the reduce function, and then in the done you actually say how you want to represent them. So let's load these 3 functions into our R session. And let's create a reference. Here I'm using another BAM file. This actually contains single end reads. It's called, and I'm setting a much larger yield size of 100,000 reads. And now I'm just going to calculate the coverage on them. You will see how quick this is. And that's it, you have your result. So I hope you enjoyed that. Here are a few references for my video. Thank you for watching.